Welcome to Intel on AI, the podcast that connects leaders with listeners. My name is Heather McGuigan, and I am your host. Today's guest is Brendan Weng. Brendan is the co-founder and CEO of Fluid Inference, an applied research lab making on-device AI fast, efficient, and accessible. The team, researchers and engineers from LinkedIn, Amazon, Microsoft, and Databricks, is focused on optimizing and fine-tuning modern-based models for real-time workloads on local devices with AI accelerators, with a current emphasis on voice AI, including speech-to-text, text-to-speech, VAD, and speaker diarization, which will expand into vision and language models soon. Brendan's path to fluid inference started with first-hand experience of AI's infrastructure challenges. At Databricks, he scaled multi-cloud Kubernetes and observability systems. At Brevian, he led an 8-engineer platform team, building distributed agent orchestration. Think sort of MapReduce for agents. When he launched Slipbox AI, the first privacy AI meeting assistant running on local AI accelerators, he hit the limits of existing solutions, which led to fluid inference. Most recently, their team collaborated with Intel engineers to bring state-of-the-art language models like Qwen3 and 5.4 Mini to Intel NPUs throughout the Intel Liftoff program. Brendan, welcome to Intel on AI.
Thank you, Heather. Great to be here.
So we've got a series of questions, so I'm going to launch right in if you're ready.
Let's do this.
So, I read, a Cliff's Notes version of your journey. So, can you tell me a little more leading up to fluid inference? What was the problem that you saw that led to its creation?
Yeah, so I spent most of my career in infra and platform, and I've always been keen to squeeze out the most performance as possible from single VM machines. Much of my early career was about optimizing and pushing the resources that were available on these devices. So when I first joined a startup in 2023, when I was helping setting up the infrastructure and platform for this large-scale agentic platform, at the time we were working with GPT 3.5, which was very early on, so the context length was very small. Thinking back now, honestly, a lot of the small language models that we have are very capable, and it reflects back to what we had back in the late 2023s. So after a brief period at the startup, growing the engineering team from to approximately 8 engineers, we tried a bunch of AI meeting note takers like Fireflies, Otters, but they were all very hard to use for ad hoc discussions, and it felt really intrusive with the meeting bot in there. And sometimes it would capture conversations it wasn't supposed to as well. And the policies that it was using for meeting data and for their training was also a little bit hard for us to accept as a team. So at that time, we decided to leave the startup and build Slipbox, which was a local first meeting AI note taker that respects your privacy and also leverages your existing device for compute. So you don't have those annoying meeting bots. And the nice thing about that is that we were running the transcription and local language models on your device. So we're able to pass off a lot of values to our user by not overcharging for transcription, not overcharging for language models. The infra side of me, when we were first building this out, it just didn't make sense because when I was looking at API costs for cloud providers, we were looking at something probably close to $20 a month just for someone with $30 or $40 an hour for transcription. So it was quite expensive, as you can imagine, with a lot of these AI apps only charging $10 a month. So from there, everything running locally just seemed like it made a ton of sense. We were looking at AI accelerators from the likes of Intel, from Apple. It seemed like the AI accelerators were already very capable of running these models locally. And also everybody's saying that cost is going down, but at this point, we're only seeing subscription costs go up. Most providers even now have $200 plans that everybody's getting used to nowadays, right? It wouldn't be long before maybe that will also go up. So we saw a lot of models are capable. And as we were building out Slipbox, however, though, we realized that it's not the hardware that's actually the bottleneck. It's more so the software. Since ChatGPT came out, chip makers have already been doubling down on their AI accelerators. And trillion operations per second for these integrated AI accelerators have already doubled since 2023. But the models were all trained on GPUs and rely on GPU for inference, which is a challenge when you try to run them locally on different devices and different platforms. So when we were trying to run these transcription models locally, we realized that even though we could run it on the GPU, but it was very draining for the end user. We have users who are using very old devices who are 3 to 4 years old. Although they have accelerators available, but running on the GPU would drain their battery, and sometimes it would even affect the video recordings when they're in meetings. So the market to run models, what we realize, is very fragmented. Every vendor is trying to figure out their own software stack, and the hardware stack is all playing catch up at this point in time. State of the art models are often being redefined every couple of months. You see new headlines with new models coming out every couple of months. So from all of our frustrations with this, trying to enable and trying to deploy models across Windows, iOS, macOS, we decided that, hey, instead of trying to focus both our efforts on this, it might make more sense to try to help everybody else unlock this. It is because at the end of the day, our ultimate goal is to try to bring intelligence to everywhere, and AI needs to be available offline all the time, and it needs to work reliably. And Fluid Inference goal is to bridge that gap.
It's a big goal.
It's cool.
You said it really simply, like, it just makes so much sense to, we'll just make sure that everybody can use it all the time.
Yeah.
There.
Now we didn't make it there.
So, in order to sort of keep going with this really, simplified but incredibly complex explanation, what exactly is fluid influence? How does it bridge the gap between advanced AI models and the hardware they run on?
Yeah, so when the reason why we chose fluid inference as a name is because we imagine that fluid flows when there's deformation, and whatever happens, it hides the deformity that it flows over. So you can think of it as a creek where there's a lot of rocks and a lot of rough edges. However, when it flows over, if all you see is the water at the top. So we want to be that layer of fluid that hides the crack and rough edges for our end users. From our past experience developing Slipbox, we experienced firsthand how cumbersome it is to develop the same AI solution across multiple platforms. So what we want to bring is a platform that allows users to give a set of requirements, a set of requirements where applications where they want to deploy to, the platforms that they want to support, and what kind of use cases they want to support. And our agents are able to go in the background, find the right models for you, find the right data set, even converting, optimizing, and even the fine tuning for your use case, and then benchmarking for your use case as well. Because what happens is when you are trying to bring these large models to local devices, oftentimes you have to quantize them, meaning you sacrifice a little bit of precision for the ability to run efficiently on devices. So we also double check that these new models that we're generating is acceptable within a certain range of error margin for your devices. Now, I think some people might be asking, Microsoft and Apple are also moving in this direction. What's the point of fluid inference, right? Why do you need something like fluid inference? Well, I would say, although they're moving in the right direction by providing foundational model frameworks and AI Foundry, but the models that they serve is also quite fragmented. Apple only supports the newest operating system, which isn't even out yet at this point. And they only support the last year generation of the iPhones that is currently being sold. As well as for Microsoft, it seems to have a stronger focus on Qualcomm-based devices. So NPU only running on Qualcomm-based devices for the new AI Foundry framework. So, but this is also just language models. We also have to think about speech to text standardization, and there's also text to speech as well, right? There's just too many variables to cover, and there's a lot of different complexities here. And you need a small startup like Fluid Inference to focus on this problem so that we can try to cover all the edges essentially.
Yeah, and the expectation that everybody has, consistently upgrading new hardware, eliminates a huge part of small businesses and populations who don't necessarily have that kind of budget. So we need to create, the kind of software that's gonna be more accessible to people.
Yeah, exactly. And actually one use case here that we are pretty excited about is that
Yeah.
because we're able to run models locally, a healthcare provider reached out to us to work together in order to bring medical scribes to areas that are more remote and cannot afford large and expensive models, because we're able to provide it at a much cheaper price with them. And this is like a nonprofit organization. So we're very excited about the opportunities that this also unlocks as well.
That's such a great feeling to know the technology that you've created is gonna directly help people.
Yeah, exactly.
Yeah. You've shifted focus from Slipbox toward fluid inference. What drove that pivot, and how has your vision evolved since?
Yeah. So Honestly, it's not entirely a pivot, but more so a fundamental change in how we operate. Slipbox will continue to be developed and maintained as a separate entity. It's just that over time, we realize that the fundamental problem is that just the market is not ready for a local AI solution without a lot of sacrifices and trade-offs for the product and also the team trying to maintain that. So when we started building Slipbox a while back, we're very excited by the capabilities of running models fully locally. But honestly, the technical challenges at hand overwhelmed us and took time away from developing the product. There's a ton of fragmentation right now, and there are startups offering trying to run unified solutions, but they're often behind restricted licensing. Chip makers have their own runtime and libraries. Operating systems have their own models, like we discussed. So for us, it felt like it was very, very difficult to try to maintain Slipbox as a product if that was only focused. So I still believe in the long-term vision that majority of AI inference will be running on local devices in a couple of years, but we lack the infrastructure and support. Now, regretfully, we should have made Slipbox open source because our value proposition for our users was that it's private and local, but it's kind of counterintuitive with a closed source solution. So with Fluid Inference, we're deciding to go with that as a completely open source solution, and we've seen a pretty good traction from the developer communities there. And luckily, I was able to find two additional co-founders who agreed with this vision, and I've worked with before in the past as well. They bring together many decades of AI and ML experience to strengthen our approach.
Awesome. How do you view the tension, the friction, the dichotomy between cloud-based AI and local inference in terms of cost, privacy, and user control?
Yeah, listen, I think this will kind of be a problem that's always been argued, regardless of whether when there was a lot of friction moving to the cloud providers first place. I saw that firsthand working at Databricks as well. When folks are moving from on-premise to cloud-based solutions, a lot of trust involved. However, I would say there's no one or the other. We need both cloud-based AI and local AI, just like how we can use our laptops for a majority of our tasks, but we still need a cloud for heavier workloads. We we will have a mixture of both, but right now I would say it's too heavily skewed towards the cloud models. Although everybody says that the cloud model costs will go down, we have not just seen that yet. And right now, a lot of these applications are subsidized by venture capital funding, and value is being given out. And for applications like Cursor, who recently increased the price or changed the pricing model, we did see quite a bit of backlash from their users. So in terms of cost, it's almost a no-brainer to run some of the models locally if possible. NVIDIA even recently published a paper supporting this as well, saying that 60% of agentic tasks could actually be performed reliably by a small model, and that these small models are the future of agents, which everybody is talking about right now.
So, with Fluid Inference, how are you helping developers and companies deploy transformer models on consumer devices without compromising on performance?
Yeah, so like we said earlier, Fluid Inference as a platform offers an end-to-end pipeline for developers and companies. We
Yeah.
provide the model, either open source or proprietary, and the requirements. Our platform leverages AI to accelerate your accelerate your time to market to production. And how we do that is our AI is able to know the requirements, gather the requirements, get the right data to fine tune your models, convert them, and to give you native format models. So Core ML, OpenVINO, whatever you need to run them efficiently directly on your AI accelerators, and even provides you, your developer, the native SDKs that you need to integrate the models in your existing application. This is automated and delivered to you at a fraction of the time that it would take for a human. It's very expensive to hire machine learning engineers to dedicated to this task alone, as state of the art is also being redefined every couple of months. So you have to run this process through every couple of months. It's a very expensive process, and it's exactly what we experienced as the boss and took away very important engineering time from the product itself. And it's also worth noting that for larger models like language models, we won't be able to achieve the same performance as cloud APIs, but as they're much more performant, just with the NVIDIA GPUs, it's very hard to match those performances. However, for static workflows like transcription and diarization, oftentimes the round trip and going to the cloud and coming back just takes more time than running it itself on your device. For one good example here is we were able to convert the latest Parakeet model, which is from NVIDIA, that is the state of the art when it comes to transcription for English language. It runs, roughly takes about 100 milliseconds for a 10-second chunk of audio to transcribe. For comparison, the fastest marketing blog that cloud providers usually publish usually quotes about a couple hundred milliseconds just to transcribe. So in general, you get better performance without any sacrifices when you run AI workloads locally. It's just that there's a lot of overhead that you need to invest in when setting it up.
You mentioned the medical partnership earlier, but what are some other exciting use cases that you're seeing emerge as AI moves towards the edge?
Yeah, so there's a ton of use cases coming out from indie developers to enterprises, from laptops, iPhones to honestly in IoT devices as well. We see that with our open source work. There's a lot of indie developers picking up our models and integrating it directly into their apps. One being a recent integration was an app called Voice Inc. Essentially, it's a open source solution alternative to apps like Whisperflow and Super Whisper, where you can speak into your device and AI is able to transcribe it and then fix it out for you, and you can just hit send. Very convenient. So beyond that, beyond consumer devices, we've also spoken with IoT companies who deploy solutions in vehicles like trucks where bandwidth is an issue, and sometimes they're often off the grid or you have very poor network connections. The hope here is that they can leverage better models to capture even more information for their drivers. And because the models are much more efficient, they're able to run them all the time instead of running them periodically or once in a while. Yeah, we also spoke to a security company working on bringing better and more intelligent monitoring to security cameras to keep businesses and just people in general much more safer, because the AI is able to run and monitor 24/7 instead of having a human there, right?
So deploying AI locally is significantly harder than using cloud APIs. Can you unpack some of the biggest hurdles you faced while building for local AI?
Yeah, so local models are deployed under resource constraints and limitations that you don't really need to think about when you're developing cloud APIs. You just plug it and it just works most of the time. But for the same platform, you have a lot of different resource configurations, like different versions of operating systems, different amount of RAM, what different versions of the CPU is available on your device. So you're very restricted and in terms of what you can offer to the user, and you need to make sure that it's all tested properly across these devices. One model may work well on the latest devices, but you completely shut off your older users there in this case. So all of this is very, very time consuming, and you need to run it in a manner where every time you change a model, you need to run through the whole pipeline again. And this is all compounded by the number of models you had to support. So for Slipbox, for example, we had to support around 3 or 4 different transcription models just because there were different versions didn't run well on certain versions. And then we quickly realized that there's also transcription, there's also diarization, there's also voice activity detection. And when we started developing the iOS version, we realized all the models that we were using for the macOS didn't work either. So all of that just compounded. And then we started developing the Windows version, which then it was another mess, which honestly, the Intel team helped quite a bit with in terms of trying to support whisper transcription language models and even diarization on the Intel NPU, because we're able to work with them to very quickly get it to market and unblock us for our Windows version. But you can imagine it's very rare to get these kind of opportunities to work with the team directly to support the chipsets itself. And this was just us as a team. And we were honestly entering into the market for Slipbox expecting that the software side of things would be solved just from what we've seen out there. However, it is quite a difficult challenge.
How have hardware advances like Intel's AI PCs with integrated NPUs unlocked new opportunities for local inference?
Yeah, so from our experience with Intel in terms of bringing state-of-the-art models to like Qwen 3 and 5 Mini and even Whisper V3 Turbo to Intel's NPUs, we saw that the latency for inference dropped by 40% from moving from the CPU to the NPU, when this was without any sacrifices to the actual accuracy itself. So with this, we're actually able to run these transcription real time and offer users real-time insights and help throughout the meeting, whereas previously from other meeting applications that we've seen, they usually run it after the meeting is done. So you're not actually able to get as much out of it within the meeting from your side. So since ChatGPT was released, we've seen chip makers like Intel invest very heavily in these integrated NPUs for your devices. And traditionally, this was not available on Windows or iPhone. Apple was one of the earlier chip makers to integrate AI accelerators directly into their devices. But with the recent release of ChatGPT, we've seen a lot of the chip makers and double down on that effort. And since 2023, we've seen the capabilities double since then. So this is very exciting as the majority of the market share is still dominated by Windows devices. And in a couple of years, as users cycle through the devices, we expect that most people will have AI accelerators in one form or another in their device.
Can you share a story or an example where Fluid Inference's approach to on device AI made a tangible difference for a customer or a partner?
Yeah, so we cannot reveal a lot of details here as we are under NDA, but
Oh, come on, spill some tea. You can do it.
will you cover the legal bills? But beyond just consumers and indie hackers, we're working with a Fortune 100 company that wants to bring intelligence to their edge devices. We brought a lot of experience from our side developing local AI applications, but also along with our platform, we're able to help them quickly unlock real-time AI workloads for them that is powered by Fluid Inference AI models. It's quite exciting because suddenly going from a small startup where we were working with smaller companies and consumers suddenly to potentially impacting millions of users across the world with our work.
That was a little bit of tea.
A
You just
little bit.
a little bit. That's like a sip. A
Just a
sip.
sip, just a sip. We can't say everything right now. Maybe for the next podcast.
Yeah. Where do you see Fluid Inference in the next 2 to 3 years? And what role do you hope it will play in advancing edge intelligence?
Yeah. So in the next 2-3 years, our hypothesis is that most AI inference will move towards the edge in the next following years. And as edge devices become a lot more capable, and smaller models are increasingly becoming much, much more capable at a very, very quick, fast pace. Just in the last couple of months, we've seen the capabilities double. And it's estimated that within a year or so, we'll have GPT-4 level models capable of running on device. We hope here that this will enable a lot more interfaces and applications unlocked by open source efforts because AI models are just so powerful that it should not be locked up behind proprietary licensing or behind certain paywalls or like wall gardens that you have out there because it's just too many things that could be done for a small team to be imagined. It's better to just give it out there, let everybody else kind of play around with it and see where we can go. We saw this with when Whisper was open source in 2023. It essentially solved transcription and it just worked for most use cases. And since then we've seen a lot of like applications like Slipbox come up, which was not capable before. And even the health medical use case we're talking about earlier, this is not imaginable before because you'd have to pay a ton of money for a solution like Microsoft's Dragon Transparent. So overall, it's very exciting to see where AI will take us in the next couple of years. Our hope for Fluid Inference is that we will be able to allow anybody to bring these large transformer models from the cloud to edge devices in a fraction of time that it takes now, while streamlining the integration for you so that it's like just deploying code. You don't have to worry about all the complexities that AI brings to the table. Right now, we're focused on audio models, and right now we're focused on laptops and phones. But our ultimate goal is to also work on visual text models, any multimodal models, and move to the edge devices that we were talking about as the capabilities of these edge devices become much more developed as well.
Amazing. I want to thank you so much for coming on the show today. I've really appreciated that conversation of sort of a cost for value and really making sure that we're efficiently looking at systems and making sure that they're accessible to a variety of clients and businesses, as well as a variety of hardware systems. So thank you so much, Brendan, for coming on the show. This was Brendan Weng from Fluid Inference. My name is Heather McGuigan, and thanks for watching another episode of Intel on AI.
Thanks for having me as well.
Visit intel.com/AI to learn more.